Hello students. So today we will begin with class 11 mathematics and have decided to start with probability, which is chapter 16. Now those of you who have just finished your 10th with your exams being cancelled, CBSE, this is the best time wherein if you have decided to take up science in your 11th and 12th, this is the best time that you start your preparations for 11th and 12th, because the foundation of mathematics is very important whether you decide to take up engineering or applied science or mathematics later after your 12th. Now you already have a basic idea about probability which you have studied in your class 9th, but we shall revisit the chapter from beginning. Now how do we begin with this chapter probability? We start with the study of this chapter by defining the outcome of an experiment. Let's say I have an experiment and I would like to find out the outcome of an experiment. Now let's assume that I toss a coin. Now when I toss a coin, which is an experiment, I'm not sure whether I would get a head or I would get a tail. But if I have an experiment where I have to find the angles of a triangle, say I have to find the angles of a triangle ABC. So I need to find A, angle B and angle C. So we know that the sum of the angles of all these three is equal to 180 degrees. So the outcome of this experiment is fixed because I need to find ABC and I need to add them, but if I add them I know that the sum will always be equal to 180 degrees. Or if I consider the sides of a right angle triangle, if this is A, B and C, according to Pythagoras theorem, we know that C square equals A square plus B square. So this condition is always true irrespective of A and B, right? So I choose a value of A and B that will be equal to C by using this formula. So therefore, the results are fixed, right? So the outcome of an experiment, of certain experiments have fixed results, but in most of the cases the outcome is not fixed. For example, I already told you tossing of a coin. So we have an outcome which can be head or tail, but it is not fixed. Or a die. When you throw a die, you are not really sure whether you would get 1, 2, 3, 4, 5 or 6. So here what happens, the result of the experiment. So this is an experiment which has been conducted. The results of the experiment are not ideal, are not the same, even if they are repeated under ideal conditions. So the results are not ideal when they are repeated in ideal conditions, and such experiments are referred to as random experiments. So these are referred to as random experiments. So again let me repeat. So I conduct the experiment under the same condition. Let's say that I am throwing a die. The first time I would get, say, a number 5. I throw a die the same way, but the next time I may get some other number. So therefore, even if you repeat the experiment under the same set of conditions, the outcome is not ideal. The outcome is not sure. You cannot predict what the output would be, and therefore such experiments are referred to as random experiments. Now these random experiments satisfy two conditions. The first one, they have more than one possible outcome. So they may have more than one possible outcome. So this is the first condition. The second condition is it is not possible for us to predict the outcome. So not possible to predict the outcome in advance. That means that if I toss a coin, I will not be able to predict whether I would get a tail or a head. So it can be either a tail or a head. So therefore it is not possible for us to predict the outcome of such an experiment. Now what is an outcome? So the result of an experiment. So result of a random experiment is referred to as an outcome, right? So for example, when I toss a die, the outcome of throwing a die would be 1 or 2 or 3 or 4 or 5 or 6. So there are 6 possible outcomes for this random experiment, that is tossing a die, right? Now the set of all possible outcomes, so you have all possible outcomes of a random experiment is referred to as sample space. So let's assume that I am tossing a die. What are all the possible outcomes? It can either be 1 or 2 or 3 or 4 or 5 or 6. So these are the set of all possible outcomes, and that is referred to as the sample space. Now if I am tossing a coin, it can either be head or tail. So the sample space would be head comma tail. Now each element or outcome of this random experiment is referred to as a sample point. So here in this case, each of them, so these are all the possible outcomes of a random experiment, they are referred to as the sample point. So with this basic introduction, let us solve the problems given in exercise 16.1. So I will leave the examples because you can always go through the examples, which are very easy to understand, right? So we shall straight away try to solve all the problems given in the exercise 16.1. So starting with the first one, so problem 1 to 7, we have to indicate the sample space, right? So the first one, a coin is tossed 3 times. So what is its sample space? So if I'm tossing a coin 3 times, I can either get head, 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 right? I can either get head, head, tail, or head, tail, head, or head, tail, tail. Or I can get tail, 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 3 times tail. I can get tail, 2 times tail and 1 times head. Or I can get a tail, a head and a tail, or a tail and 2 heads. So remember that you're tossing a coin 3 times, so you would have 8 different outcomes, right? So the sample space here has 8 different outcomes. The second one, a die is thrown 2 times, right? So what is its sample space? So when a die is thrown 2 times, I can get 1, 1. The first time I would get a 1, the second time I would get 1. Or if I get 1 first time, I can get 2 the second time. Or 1 being common, the first time I can get 1, 3, next 1, 4, and so on up to 1, 6. So I have 6 possible outcomes here. Now the first time I get 2 and second time 1, then I would have 2, 2, again so on up to 2, 6. So similarly 6, 1, all the way so on up to 6, 6. So I have how many outcomes? 6 each into 6, so I have 36 outcomes. So 36 possibilities I have. So similarly the third one, if a coin is tossed 4 times. So remember, a coin is tossed 4 times. So what happens? I would get 2 power 4, that is 16 combinations, isn't it? So I would get 4 times head, or 3 times head and a tail, and so on. All right, up to getting tail 4 times. So you have 16 combinations, right? So make sure that you write all of them. Fourth one, a coin and a die is thrown. So if you have a coin and a die which is thrown, now let's assume that a coin is thrown, I get a head, and then you throw a die, I will get 1. Next, for head, I can get 2. For head, I can get 3, 4, 5, or 6. Or if the first time I would get a tail, then I can get 1, 2, 3, tail with 4, 5, and 6. So this happens to be the sample space. 5. A coin is tossed and then a die is rolled in case of a head is shown on the coin. Now what happens in this case? If you get a tail, then we end the experiment, right? So I have a tail here. This happens to be one of the outcome. The condition is if you get a head, then you're going to roll the die. So I have got a head here, so I roll the die, I may get 1. Get a head, I roll the die, I get 2. So head 3, head 4, head 5, and head 6. Right? So you have 7 possible outcomes. Sixth one, 2 boys and 2 girls are in room X, and 1 boy and 3 girls, they are in room Y. Find the sample space if a room is selected, then the person. Alright, so what happens if I select the room X? Then I am selecting one of them. So let's say I select boy 1, or I select room X, I select boy 2, or I select room X, girl 1, select room X, girl 2, or if I select room Y, I select the boy here. So let me call him as B3. Next, room Y, you have 3 girls here. So G1, G2 are the 2 girls who are in room X. So here let them be G3, G4, G5. So G4, room Y, G3, room Y, G5. Right? Okay. So this is the sample space. Next, 7th one, 1 die of red, 1 die of white, and 1 die of blue is in the bag. 1 die is selected at random and is rolled. Its color and number on the uppermost face is noted. Alright, so what is the sample space? So the sample space is this. So I select one of the die. So if I select, say, the red die and I roll it, so I would get, say, 1. So I note the color red and I also note the number. So similarly, again I select, if I get red, I roll it, I get 2. So similarly R3, R4, R5 and R6. If I am getting the white die, again I roll it. So I am actually noting down the color also. So I get W1, W2, W3, W4, W5 and W6. If I am again rolling the die, if I get the color blue, and then I get 1, 2, 3, 4, 5 and 6. Now why am I writing R, W and B here? Because I am noting down the color and then I am rolling the die and I get the number. The 8th question, an experiment of recording boy-girl composition of families with 2 children. So first you need to write the sample space if it is a boy or a girl in order of their births, right? So a family of 2 children. So let's assume that the first child is a boy, the next child can be a boy. Or if the first child is boy, the next one can be a girl. Or if the first child is girl, the next child can be a boy, or you can have 2 girls. So that's the sample space of the first one. The next one, find the sample space of number of girls in the family. So what about number of girls in the family? It has been given that the family has 2 children. So there can be a case where there are no girls, that means both of them are boys, so it is 0. Or there can be 1 girl, 1 or 2 girls. So the sample space is 0, 1 and 2. Very simple one. Next, 9th one, a box, 1 red, and so there is a box having 1 red and 3 white identical balls. So 2 balls are drawn at random in succession without replacement. So what is the sample space? So the sample space is, so I am actually drawing 2 balls. So there is a box and inside this box there are 4 balls. One is red, the other 3 are white, and these 3 are identical. So I draw 1 ball, I keep that ball here and I draw 1 more. So in the first case I can get a red ball and I have 3 remaining white, so I have to get a white. Or if I draw a white ball first, the next one I can get a red. Or if the first ball what I get is white and the next time also I may get a white ball. Right? So this happens to be the sample space. Next, 10th one, toss a coin, throw it the second time if head occurs. So if you have head, what are you going to do? You're going to toss it once again. Toss again. Now if I get a tail, then I'm going to roll a die. Very simple. So first time I toss, I get a head. So what are you going to do? I'm going to toss the coin again. So I may get a head again. Or if I get a head, I toss the coin again, I may get a tail. Next, for the first time if I toss, if I get a tail, then I'm going to roll a die. So I may get a 1. So first time I get tail, I roll a die, I may get 2. Then again T3, T4, T5 and T6. Right? I hope it's clear. So if I get a tail, then I'm going to roll a die. So you have 6 options. You may get 1, 2, 3, 4, 5 or 6. So this happens to be the sample space for the question 10. 11th one, 3 bulbs are selected at random from a lot. So you may have defective or non-defective. Write the sample space. So you're actually going to select 3 bulbs. So if I select 3 bulbs, all the 3 may be defective, or 2 may be defective and 1 not defective, or defective, not defective, defective, or defective NN. Or the next time if I get not defective, then I have defective, 2 of them I may get, or NDN or NND or NNN. So again I have 8 combinations here, very similar to tossing a coin 3 times. So instead of head or tail, I have defective and non-defective. The 12th one, a coin is tossed. If the outcome is head, a die is thrown. So you toss a coin. If I get a head, you toss a die, or a die is thrown. If the die is even, you throw it again. All right. Okay, so I begin the experiment. So if I get a tail first, I stop it there itself. The next one, if I get a head, I'm going to throw a die. If the outcome is odd, then I stop there. So head, an odd number, head, an odd number, head, an odd number. So we stop the experiment. But if I get a head and an even number, what is done? You are again throwing the die. So in that case, I may get 1, then H22, H23, H24, H25, and then H26. I have a head. If I get an even number 4, again I am throwing the die. So I may get H41, H42 up to H46. Again I may get a head, an even number 6. Again I throw a die, I may get 1, H62 up to H66. So this is the sample space. Question 13. The numbers 1, 2, 3 and 4 are written separately on 4 slips of paper. The slips are put in a box and a person removes 2 slips without replacement. So I have all these 4 slips in a box, 1, 2, 3, 4. Okay. So now what happens? Let's say I get 1. The next time I may select 2. Or if I get 1 first, then I may get 3 the next time, or 1 and 4 next time. So these are the combinations if I get 1 first. Or if I select 2, if I take this slip 2, then I might get 1 the next time, 2, 3, 2, 4. Because the slips are not being replaced, you have to keep that in mind. Or if I get 3 first, the next time I may get 1, 3 first, next time 2, 3 first, next time 4. Or if I select slip 4 first, next time 1, 4, next time 2, 4, next time 3. So these are all the possible outcomes. Question 14, you roll a die and then we toss a coin if the die is even. So if you get an even number, then we toss a coin. If it is odd, then toss coin twice. So let's begin with the first one. If I get an even number, say 2, I'm tossing the coin, so I may get head. If I get 2, I toss a coin, I get tail. Or 4, even number, toss a coin, I may get head. 4, toss a coin, I get tail. Or 6, head, 6, tail. Now if I get an odd number, then what am I doing? I'm actually tossing the coin twice, so I can get head, head, 1, head, tail, 1, tail, head, 1, tail, tail. Or the next time, if I get the odd number 3, again I would get head, head, 3, HT, 3, TH, 3, TT. Or the first time I get 5, again I toss the coin twice, HH, HT, TH, TT. So this happens to be the sample space for the question 14. 15th one, a coin is tossed. If it is a tail, then we draw a ball from the box. And the box has 2 red and 3 black balls. If it is head, right, you throw a die. So let's begin with the first one. So if the sample space S is, if I get a head, I'm going to throw a die. So I may get 1, 2, or 3, or 4, or 5, or 6. So I've completed with the head. Now if I get a tail, I'm going to select one of the balls from the box. So I may get the first red ball, or I may get the second red ball, or I may get the first black ball, or the second one, or the third one. So this happens to be the sample space. 16th one, a die is thrown repeatedly till 6 comes up. So then what happens here? The sample space is almost endless. So I have the sample space. If I get 6, I stop here. Next, if I get 1, then I throw the die again so that I get a 6. So if I get a 6, I stop here. Next, if I get 2, the second time I throw, I get 6, I stop. So similarly like that, if I get 5 first time, second time I get a 6, I stop here. Or the first time I get 1, the second time I get 1, the third time I get a 6, I stop here. The first time I get a 1, the next time I get a 2, the third time I get a 6, I stop here, and this continues, right? So up to 1, 5, 6. So this is endless. First time I get a 1, second time I get a 1, third, I may get 1 10 times and 6 11th time. So I stop here. So therefore the sample space is endless. So it's infinite. So you may get 100 times, and the 101st time I may get 6 here. Or I may get all the numbers 1 to 5 100 times, and then I may get a 6. So I stop there. So this is an experiment where you keep on throwing the die repeatedly till you get 6. So what is the sample space? So theoretically it's infinite, right? So here in this lecture we have solved all the problems given in the first exercise, exercise 16.1, right? And we have also gone through some of the most important concepts. We have defined what is a random experiment, we have defined what is an event, we have defined what is an outcome, and we also have seen how we can find the sample space for various problems. In the next lecture we shall see what are the different types of events, algebra of events, what is a mutually exclusive event and what is an exhaustive event, and we shall solve problems given in the second exercise 16.2. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and keep a watch on the channel to view all the other videos in maths for class 11. And thanks for watching.